Hello everyone, I'm Aruna Baijal and I'm excited to talk about my experience in ENPM809T. So let's just dive right straight into it. First, we started building the software components. So that included checking if our Raspberry Pi is starting up, whether our camera is integrated well into it or not, and whether we are seeing what we're expecting to see. Then we started building code on top of our sensors, which is like how we are seeing here. We're tracking the green circle and we're marking that contour out. Over here, we're trying to see if we can detect the arrow mark and also infer what is the direction of the arrow mark. Apart from these software components, we also had to work on some hardware components. This was a very exciting phase for me because it's the first time I worked on hardware. So just building the robot from scratch, building its chassis, adding all the wiring conditions, soldering onto it, and actually repeating the process multiple times because I would mess up somewhere or the other, and making sure that all the connections are strong and no voltage is leaking anywhere. There were multiple iterations of our hardware building system spread over a few weeks, which was pretty good because it has broken down one entire robot building project over a few weeks, and we could actually appreciate each individual component and see how each object interacts with other objects. How are you wiring each object together? What sensor is activated by what part of the code and things like that. Just building it from scratch gave me a lot more insight than what I would have gotten from just getting a ready-made robot. And over here, you can see that at every point you would check some 100 times on the slides. Is it the correct wire that I'm attaching? Because you would not want to short circuit your Raspberry Pi or any other connection for that matter. This was a very fun process for me. That after wiring everything on, you turn it on and you see the wheels moving. And you can see the distance sensor providing you a distance, the camera giving you your face right back at you. So this was one of my favorite parts of the course. And I was glad that it did go on for as long as it did. And I had enough time to actually appreciate the engineering aspect of it. And you might not see it in the video, but most of the times I was just grinning away. Over here, you can see that I'm making sure all of the connections are strong, nothing's moving. Now came the next part of testing each component that we would need in the grand challenge. Here I'm teleoperating the robot to move forward, turn left, turn right, move back, make sure that the wheels are all turning, there's no friction going on between the encoders. And it was fun to see that the robot has come to life and it is moving as you want it to move. Then the next part came about where you're giving the robot instructions that it's supposed to move for a particular distance or it's supposed to turn in some particular direction. Like over here, I'm operating it with arrow keys and the robot doesn't know what it's going to do. Over here, we're doing the same thing, but we're also checking our gripper. So we're moving around looking for the object, holding it, pulling it back, going somewhere else. Here the robot is supposed to move exactly 1 meter. So this included us figuring it out. How are you tracking the distance traveled using encoders, and what are supposed to be the threshold values, and whether the two wheels are rotating at the same rate or not. And actually realizing that such an issue can come up, that two wheels will not rotate at the same rate because they're two different systems, even if you're providing them with the same voltage, same current, and things like that. Here we're trying to move the robot by a particular angle. So here it's supposed to rotate exactly 90 degrees left, and then rotate 90 degrees back, right? This experiment also helped us appreciate the amount of friction that's going on the wheel. So even if the robot's trying to move due to slippage, it's not being able to move. Here we are trying to create a rectangle, and we are trying to create that perfect rectangle using just encoder data or just using IMU data. Uh, just by comparing the two, we can see that the left is the encoder data, where it's moving the correct amount, but it's not straight. Whereas on the right with IMU data, it's moving perfectly straight, but I'm unable to actually control the amount that it has moved. So this was an issue that we had to solve for the grand challenge. Here we are just trying to track a particular color of while or any object. So if you're moving it around the scene, it should be tracked by the robot. And here you can see itself correcting itself, or rather overcorrecting. So going through all of these steps, we realize that you have to tune the parameters of your controllers. Here the task was to grab the correct object from a cluttered environment and bring it back. So all these small components are actually what we built upon to go to our grand challenge. And this is my experience of the grand challenge. I've just sped up the entire run for my robot, and I was glad to say that it did work out pretty well for me. Uh, I was able to deliver 2 whiles out of 3. Even for the third round, my robot did complete the entire third run, but it just did not have the while with it. So sort of a wasted run, but at least we had the reassurance that the robot could travel on its own and follow the required path. Here it localizes itself using arrows, and at the pickup and drop off point, it localizes itself using these QR codes. So even if our calculated distances are missed because of any reason, it can at every point localize itself using these arrows or QR codes to correct its course. So it was a robust way to make sure that the robot still moves as is expected, uh, given any variation between these localization points. Like here again, it localizes itself using the green arrow, and it shall move and look for the third while. But since it was out of its field of view, unfortunately for the third round, it could not pick up the third while. But I had still made the code robust that even if it does not find the while, it should continue with the rest of the run. And it did exactly that. It went ahead, assuming that it had the while, and it did everything else that was expected of it. Even actually going ahead and looking for a face to drop the while, even if it did not have a while. And I was pretty happy with my experience. Now comes the fun part, which are the many bloopers that I had while preparing for this grand challenge. Like you can see here, it was difficult to get it running on the carpet surface. No matter the angle I give, it'll go somewhere else. Here, I was facing problems with IMU, where it will give a static value and then the robot would just go berserk. And a very lesser discussed issue is the number of times you would drop your camera. Finally, we see the trajectory that my robot took towards the grand challenge. For each run, it starts at the bottom left corner, the cold storage area, and navigates towards the top right corner, the injection area, and then back to the cold storage area. The red, green, and blue lines are for the respective aisles.